In this topic, we will learn about few special examples of vectors. What are the examples? Surface, force, centripetal force, torque, and angular momentum. Okay. Generally, we take the surface of a body as a scalar quantity, but in higher studies or calculation, in case of gravitational field, in case of electric or magnetic field, we take surface as a vector quantity. Direction of surface. Direction of the surface is see, you are looking at my screen. I am writing at the screen and you are looking at your screen. Take your screen as a surface. Now what do you see? You see the surface of the screen is looking at you. It is looking at you. For this reason you can see the screen, otherwise you couldn't have seen the screen. So we can say the direction of the surface is towards you. Or if the surface is taken like this, then the direction of this surface is towards this point. Okay, now how do we denote this direction? How? See the structure of an arrow. This is an arrow. It has feathers on the back side. Okay, if the arrowhead is looking at you, if it is coming towards you, what will you see? You will see the frontal peak point of the arrow. Now if the arrow is going towards the screen from you, if the arrow is going towards the screen from you, you will see that the back part, you will see the back part which is like this, like a cross. In practically the feather is like this, but in physics we will denote it as a cross. Okay, so in every case we can say the direction of the surface of a body is like this dot whenever you are looking at the surface. But if the surface has opposite direction, then we will write it as a cross. Now we come to the next point, which is force. So what is a force? Force is an external cause for which the state of a body is changed. What do we do to cause a change in the state of the body? We push or pull the body. This is called force. Whenever suppose this is a box, you are pushing the box towards that side, this force has a definite direction, and if you pull the box, then this is the opposite direction. That means what? That means force has a direction. Now in case of gravitational force, we know the gravitational force acts towards the center of a body. So if you are standing on earth, then your attraction is towards the center. This is called gravitational force, and gravitational force has also got a direction. So force is a vector quantity. Now we come to the third topic, which is centripetal force. So what is a centripetal force? When a body revolves in a circular path, a force acting on the body in the direction of the center of the circle. The force is acted towards the center of the body. Along the radius keeps the body in circular motion. Due to this centripetal force, the body is kept in motion. This force is called centripetal force. Okay, now see, if the force, attraction force, acts towards the center, then the object would always come to the center, not rotate in a certain axis. So how does it revolve around a certain axis? It revolves because there is another type of force that is neutralizing the centripetal force, and thus the body can be kept at its position, and the neutralizing force is called centrifugal force. From Newton's third law, we know that every action has an equal and an opposite reaction. So this action is neutralized by this equal and opposite reaction. Since the centripetal force has a direction which is towards the center of the circle, this is called, centripetal force is called a vector quantity. And the centrifugal force acts towards outwards direction, so centrifugal force is also a vector quantity. Now coming to the fourth topic, which is torque. In order to understand torque, you need to take an example. Suppose this is a door. Whenever you push here, from here, whenever you push, the door is revolved around a certain axis. What? The door is revolved around a certain axis. So this is an example of torque. So what is a torque? Torque is when a single force or a pair of equal and opposite and parallel forces acting on a body rotates it about a point or an axis. Which one is the point here? This one, the hinge part of the door. Then the quantity which is responsible for the angular acceleration is known as moment of force or torque. So what is the second name of torque? Moment of force. Now coming to our fifth vector quantity, angular momentum. Now what is the angular momentum? We all know that momentum is the product of mass and velocity. Previously we called it momentum. Now we will call it linear momentum. Now what is an angular momentum? The same quantity as the linear momentum that works in rotational motion. When momentum works linearly, we call it linear momentum. When momentum works in rotational motion, we call it angular momentum. The formula of angular momentum is L equals to mvr. This radius is the radius of circular orbit, and the direction of angular momentum is, suppose an object is revolving, keeping the center here. Now the direction of angular momentum would be perpendicular to the plane of motion. Now what is the perpendicular direction? The perpendicular direction would be, if you apply right hand rule, we can say the direction would be this one or this one, towards you or towards the surface. So this is the end of this topic.